another concept. Today we will study that potential, how to calculate the potential due to induced charges on a conductor. This is a very important concept as far as IIT JEE Advanced is concerned. So I'll explain this concept with two examples. First of all, in this video I am demonstrating one example, that I have taken a conducting sphere whose radius is r, and there are 2 points inside it. This point O, it is a hollow sphere, or it doesn't matter that it is a hollow or it is a solid conducting sphere as far as it is conducting. So there is 2 points. One point is O, and O is the center of the sphere, and other point is P. P is some other point. Okay. Now this sphere is neutral also, and there is a charge Q which is kept at a distance of r1 from the center of the sphere, outside it. Now we know that due to this charge Q, there will be a induced charge appearing on this sphere, like that, if we are assuming Q to be positive. Now the sphere is having all the points on its surface which are equidistant from center, and all the induced charge on this metallic sphere resides on its surface. Therefore, I am saying that all the induced charge on the metallic sphere is equidistant from its center, and the net induced charge on any conductor is always 0. Okay, so hence the potential due to this induced charge, whose net charge is 0, will be 0 at the center, because the potential which is created by this positive charge at the center will be equal to the potential which is created by this negative charge at the center. Okay, so first thing is the fact that the potential due to induced charge at the center is 0. So I can write the option A, potential due to induced charge at O is 0. This is correct. Now option number B, potential due to Q at O is equal to KQ upon R1. This is also correct. Then C, potential at P is equal to KQ by R1. Now this is also correct. Why I am saying so? Because we all know that electric field inside the metal is 0, which makes the volume of metal as equipotential volume, which means that at each point inside the metal the potential is same. Okay, and that same potential is equal to the potential of center. So we have already calculated the potential of center to be KQ by R1. This is also, first of all, I am writing the net potential at O. So net potential at O will be the sum of these two potentials, and hence option number C is correct. Now option number D, that net potential at P will be equal to KQ by R1. Now I am saying that this is also correct, because the potential at O and potential at P should be same, because these both points lie inside the equipotential volume of metal. Hence the potential at P and potential at O, in fact the potential at all the points which are lying inside this sphere as well as the points which are lying on the surface of the sphere will be equal to that potential which is at center of the sphere, which is equal to KQ by R. This is a concept. So this is also correct. But we also know that potential due to Q at P is equal to KQ by R2, due to the fact that this point charge is at a distance of R2 from P. This is also correct. I'm not saying that potential at P, net potential at P, I'm saying that potential due to Q at P. Now, how it is possible? So, I'll demonstrate that potential at P is equal to potential due to Q at P plus potential due to induced charges at P. Because P is not symmetrically placed inside the sphere. In fact, P is more nearer to positive charge and it is far from negative charge. So, the P is not symmetric in the sphere, hence all the charges are not at equal distance from P. Therefore, we can say that the potential of induced charges or the potential due to a sphere at P is not zero. So, how will we calculate it? That V at P is equal to KQ by R1 is equal to V due to Q at P. This is KQ by R2 plus V due to induced charges at P. So V due to induced charges at P is equal to KQ common 1 upon R1 minus 1 upon R2. And you can also see that R2 is greater than R1. So 1 upon R1 is greater than 1 upon R2. Hence, the potential at P due to induced charges will be positive in this case. And it should be positive as P is more nearer to the positive induced charge. Okay, I hope you understand this example, that how you will calculate the potential due to induced charges. I will come up with another example illustrating this concept. Thank you.